Hello there, this is John Everest, and I'm on to the second tutorial for going through the Honeybee Plus three-phase standard tutorial. So here it is, and in the previous tutorial we've corrected there were errors coming here purely because this tutorial has been made in version 5 of Honeybee that is not currently the current stable release is Honeybee point 4. The tutorial is made in Honeybee version 5, and it causes a few errors. So we've corrected all those errors. Now, what I want to talk you through is I'll do a real quick recap here. So this is about the sky matrix. This is about the sunlight coming in. We take the weather file, the Energy Plus weather file. It has all sorts of data in it. We only want data relating to lighting, and we translate it into a WEA format, which is what Radiance uses. It goes in here, then Radiance is able to take that data and turn it into a sky matrix, which is the light intensity for every hour of the year for a sky dome. Yeah, and it is then fed into the three-phase grid-based recipe. It also into here also goes the calculation grid. Yeah, so that is a calculation grid based. Usually you just take floor area, you lift the grid 0.75 off the floor, and you make the analysis grid, and you plug that in, right? And here is the and here's the reference model that comes with the tutorial, right? And maybe if I do that 50/50, this is going to make a bit more sense. Overlap that slightly, right? Okay, now we go on to geometry preparation. So there's actually, think of it like this, there are four types of geometry. Four, right? The first are opaque surfaces, Honeybee surfaces. These are the opaque surfaces. These are your walls, floors, ceilings, and the exterior envelope of your building, right? And you in this case, Honeybee's pretty clever, and it will assign radiance materials, i.e., it will give your floor, I don't know, like 20%, your walls 50%, and your ceilings, the standard 70%. But you could do that yourself if you could do that yourself if you want. Okay, so that's nice and easy, isn't it? That's just simply the opaque surfaces. Yeah, done. And this one here is just giving you the outline as a reference. If we switch that on there, yeah. But rightly so. Leave that off, and it's a bit less confusing. Right. Next, then we have two types of windows. Yeah, two types of windows. We have window surfaces and window groups. Window surfaces, and I don't quite understand the logic for doing it this way, but when you have a window surface, firstly, you don't have to assign anything in a window surface. I could delete this and the calc would still run just fine. But what it does is when you hit calc, for reasons I don't understand, I've asked a question on the forum because perhaps I'm missing a trick here, but when you click calc and it runs, you're running a three-phase calc. The first thing it does is run a two-phase calc. And I don't understand why it does that. But um, so any windows you put in here will be included in the two-phase calc, right? And it's actually a DDS two-phase calc as well, so it kind of does a really accurate sunlight contribution. These windows here, these are your other windows. They just get blacked out, and it just does that complete calc there. So I mean, I'm going to leave it as is for the tutorial, but when I was actually working with it, I was said, well, if I want a two-phase calc, I will select the two-phase calc, and I just leave that blank, and it just wastes a load of time calculating a room with no windows. And as I say, the only way I think I could see this having a purpose is if you were adding windows to a room. Say, imagine there's a room that already had windows, and you're asking the question, well, I don't know, what if I added blinds or like a treatment to an existing window? No, even that wouldn't make sense. If I have a window in a room and it's not going to change in the slightest, it would make sense to put it here, and I experiment with my new windows with the three-phase components over here, which I'll go into. I don't know why it does it, but anyway, so uh, actually I could have been a bit more organized, right? So See that? The side windows are the window surfaces. These are the windows that will be included in the first calc that I don't see the point of, right? Okay. Then we have the skylight. Now, when you have the Honeybee window groups, right, these are the ones that will be part of the three-phase calc, your three-phase calc. So what it will do is it will take it will take these will become blacked out. It will use this geometry for your view matrix, and down here it will calculate the contributions from these windows. So in this case, the skylight, and in that case, the south window, a proper three-phase calc, which is what I want when I use the three-phase calc recipe. Okay. I don't. Can I make that any more simpler? I don't think I can. I mean, if you don't know what a three-phase calc is, that's go look at the calculation methods. Right. Uh, and then down here, so the fourth is, so we have one opaque. So we have opaque surface, two types of windows, and the context is just basically if you just have some generic geometry, like, you know, beyond your control. So you're building a building here, and there's a building here, and, you know, whatever, there's uh, I don't know. Yeah, there's you know, you have no control over, you know, obviously the context around the building. Yeah, so you'd put it into here. Yeah, and it will just stick it all in there. To be honest, there's not really any difference between well, that I can understand anyway. There's not really any difference between the radiant scene and the honeybee surface. They both do exactly the same thing. They all just get bundled together and put into the calc. But I guess it does make it's a nicer organisation, isn't it? When you know that yeah, this is my context buildings, and this is the envelope of the building I'm working with, right? I'll just delete those. There we go, lovely. So yeah, and yeah, I mean, and as with the context buildings and the just the radiant surfaces, you know, you obviously need to. Okay, here as well. Like, oh yeah, okay. So it can just be a completely different folder. This stuff is straightforward. Yeah, that stuff's all straightforward. But I need to spend a little more time talking you through. I think that's pretty straightforward as well. If you don't assign a material, it will just assign a generic 60% transmission clear glass, which is a pretty decent approximation, isn't it, of a generic piece of glass, double glazed glass. Right. When you come to the window groups, what it's actually doing is it will group together no matter how many windows you have in here. Yeah, so here there's only one window in the group, but it could be it like these two here could be a group. It could be as many windows as you want in the group, right? And it's the same thing there. So as many windows as you want in this brep, you feed it in. Yeah, you give them a name, you give them the radiance material. Now, this material has to be the XML file. This is your by scattering distribution function. I think that's it. By scattering distribution function material. Yeah. So if it's just a clear piece of glass, you need to go and find the XML file that describes that. You can get it off the Honeybee website, or you can get it from. Hang on a minute, I did make a note of this. Oh, is that the link to the tools as well? Oh wow, I've got some. Yeah. Okay. Let me just show you this. If you want to get some the by scattering direction function files, just go here. Is that going to come up? Yeah, you can get, yeah. And so here's a very, is that 1% vertical light transmission all the way down to 50 vertical light transmission. And I think on, you know, go on to the next page and it will give you clear, then it will give you diffuse transmission. Yeah. Okay, that's where you get those files. If you want to download the sample files, I should have put this at the beginning of the tutorial, couldn't I? It's more organized than I thought. Yeah, this is where the sample files exist. Although, how the hell are you going to read all that, eh? But yeah, it comes off GitHub, and you get it all from there. Okay, right. I've gone on for a while, haven't I? So I need to cut the video again. And no, wait. I'm gonna let me finish this up. Right. So you have to assign your geometry to that group. Now notice that once you assign everything that you assign to the same group will have the same distribution. So the light coming from them will be identical. Yeah, it will collect all the light. It will collect all the light externally from all these surfaces, and it will give you the average of all the surfaces into the room. If that makes sense. And my point being is you can't say that's a group like that fitting and that fitting, that window, the skylight and the side light is a group, because they're two totally different ones. If you had a window there and a window there, providing there's no sort of obstruction that makes the light wildly different, that would work, yeah. Um, but also you could not have that window and that window as a group because they have fundamentally different light coming into them. So it needs to be windows of similar. They can be different shapes because the pattern of light coming in will be the same. But what's important is if you're going to put them in the same group, they have to receive the same intensity of light as each other. Otherwise, just either weird things are going to happen or you're going to get no results at all. I think I don't know what would happen if you put those into the same group. I mean, it would be wrong, that's for sure. Okay, so that's when you put your geometries in, they need to be of similar orientation and location. The shape can be different. Okay, name is obvious. Radiance material we've just talked about. This is just leave that to manage itself, provided you're not doing anything really complicated. And the final thing that might confuse you are states, right? And and again, you don't have to have different states. I could unplug that and it's going to work just fine. And what a state is so this is for the south window. What we're saying is there's a default state, right? The default state comes from here, and it is can you see that on the middle line there? It's the clear glass, right? So by default, it's going to run that. But it's going to run another calculation in state 1 because we have assigned it an extra state. And that state is going to be the other material. Do you remember in the tutorial files, look, there's a clear and a diffuse, right? So clear, diffuse, right? And this one is, can you see in the middle line there? Diffuse 50. So state like default state 1 is exactly the same piece of the same geometry of glass, same position of glass, size of glass, except it is no longer a clear piece of glass. It is a diffuse one, and it is gonna sort of, and this is the trick of the three-phase method. It is going to calculate both of them, and on the other side of the calc, you can reassemble the results as you choose. What are the results like using the skylight, the side lights, clear glass? And what are the results like using side light, skylight, diffuse glass? You don't have to rerun the calc. You're basically doing all your calculations up front. Actually, it's actually quicker than that, to be honest, because it's again, I don't want to go into too much detail, but it's true parametric analysis. Okay. I'm going to cut the video. I hope I've given you a fighting chance on this side of the calc, and I'm going to show you the batch file next, and then we will go on to the results. Right, see you on the other side.